Does this drive?
No, I have not plugged it in, so that's why it doesn't drive. Is there, how does it connect? So USB?
I would assume there's one. I don't see one on the channel.
You just give me hand signs and I'll move.
All right. Ready?
Good. Give it another 10 seconds.
Good afternoon, everyone. Welcome. This is DOTS. My name is Roman Daniliu, and I'm co-chairing with
Tobias Gondrom.
This feels like on television. Sorry.
So the first thing I'd remind everyone about the note well, you've seen it before. If you have kind of any questions, please don't hesitate to stop the conversation to pose what might not be clear to you. Administratively, we have a JavaScribe, thank you, note taker, thank you. We have blue sheets that we're passing around. Please do kind of write down your name, and when you're done in the back, please raise your hand. We'll take the clipboard from you. We have a very full agenda today. This is the one that was posted last week on the mailing list. We're going to have a use case conversation, a requirements conversation, an architecture conversation, and then lastly, we're going to end with talking about a number of the solutions-oriented drafts, and then a smidge of time for open mic. Would anyone like to bash this agenda? Okay, we'll take the agenda as it is. Next slide. So since the last time we met in Buenos Aires, a couple of events have occurred, and I wanted to point out one that's going to happen this week. First, we had an interim meeting in June. A number of good, healthy conversations occurred surrounding the architecture requirements and use cases. There are proceedings, there are minutes. Please feel free to follow the URL there. Everything's written up. Earlier this week, we had a design team meeting to talk about use case architecture and requirements together, another good productive design team conversation. And I would just reiterate what we've said on the mailing list. Tomorrow, there will be an implementers design team meeting at over the lunch slot, 12:30 to 2 in Koe Penick 3. So please do come, and we're hopeful that people that have running code with DOTS will kind of come to talk about where they stand with their implementations, which drafts they're building against, and what are some of their early lessons learned. We had the virtual interim meeting in June. That was actually a kind of real success to have an intermediate checkpoint. What's going to happen again in about 6 weeks, so halfway between now and Seoul, we'll put out a poll to find out what the optimal time is to schedule the next interim. Document-wise, we have an updated requirements document. We have a newly accepted architecture document. Previously, this was an individual draft. And we have 4 individual protocol drafts that were also revised. Next slide. Just to remind everyone where we stand with milestones, from Buenos Aires, we agreed to slip everything. So use case and requirements now in November. Data model and transport moves till after Chicago, but before Prague in March. And then the other milestone that's actually a new one in there that I'm putting out as proposed is that since the architecture document has been adopted, that we put a marker out there for the submission at the same time as the use case and requirements in November. Does anyone have feedback on that new proposed milestone? Is anyone against that?
Fleming Andreasen. Sorry, no, but again, data model, we don't have a document right now, right?
That is accurate.
Okay. Seems optimistic then.
I concur with that optimism.
Frank Xia, I think if we talk about the data model document, I think we have some solution draft. Which include some data model content. So I think we have already done some work on this part.
Fleming Andreasen. Yeah, I mean, that's true, but I think we would really benefit from actually having a data model document, right? That tease that apart, because we get different protocol proposals, and the question is, how do we evaluate those? And I think just having more discussion around the data model and something that we could point to, I think it would be very useful. But of course, somebody's got to do it.
So at the mic, are you volunteering?
I guess I would have to at this point, right? Yeah. I would volunteer if I can get somebody to help me, most definitely. So.
Okay, a second volunteer there. So then maybe, okay, we take this up. Yeah.
Perfect, thank you. So with that, that's our current status going into this meeting. That's where we stand with milestones. And so we have a full agenda. So the first thing we'd like to open with is a discussion of use cases. So Roland, please. And if you could stand in the magic pink box there for us.
Okay, great. I forgot my clicky, so.
Don't worry, I'm your clicky.
Okay.
Just give me a hand sign.
All right, very good. Hi, I'm Roland Davins with Urban Networks, and here to give an update on use cases. If we could advance the slides, please. O2 still a work in progress. We hope to rev it pretty soon here. We're consolidating some of the use cases and language from draft Nishizuka. We're refactoring the document significantly. We want to be able to describe a minimum viable capability for DOTS that is necessary in order to fulfill the main function of DOTS, which is threat signaling to get assistance in time of an actual DDoS attack. The language in the previous drafts was somewhat dry and abstruse and repetitive, and so we are basically doing a stylistic rewrite more than anything else to make it more accessible to non-specialists, to serve as an educational document for folks who are interested in the topic, as well as to serve as a reference to be used for requirements and the other drafts as well. We have some verbiage that's duplicated throughout the current draft. We want to get rid of all of that stuff. The new use cases are more general role-based types of use cases, and they'll be in a more narrative type of format. We're still going to keep the existing A, B, C, D, E lists of what we emphasize the messaging exchanges to be, but we're going to move that back to an appendix as a reference. And we've added some additional co-authors as well. Next slide, please. We are really interested in broadening our participation. We have a core group of about 7 to 8 folks who've contributed a lot so far, and we have some good verbiage from those folks that we're going to work into the O2 of the draft. But please, if you have use cases or what you think would be a potential use case, please send them out. And we ask that you actually send any new use cases that you'd like to be considered, as well as feedback on the draft. Send it to the list, because that way everybody can see it and comment on it. It really makes for a broader discussion. The folks we have who have contributed so far are very experienced with various roles in the industry and experience with DDoS attacks. But again, we would really like to see some broader participation and commentary. So please send it our way on the list. The O2 revision will be a major update. Next slide, please. That's all I had.
Questions? Okay, maybe one small comment from the chairs. As you've seen before, the milestone for this to go into working group last call will be November, which means if you do have use cases, then you have a relatively short time window to submit them. And we will be looking forward to the next steps. And yeah, thank you.
Yeah, we anticipate in 03 and possibly in 04. So O2 is to make the major structural changes, and then refinement in 03 and possibly in 04 before we believe that we're ready for November. So we're going to rev it pretty quickly.
Hi, Andrew Mortensen, Urban Networks. Is there a working copy of the O2 draft somewhere, or is that
not at this point in time, but there will be, and we'll send it out to the list.
So what would really help with this document progressing is twofold. I mean, we just talked about please provide a review. If there are more use cases that are not currently articulated now, even if you don't have a lot of text around them, if you could identify them, and so we could have placeholders in the document and we can continue iterating, that would be really helpful. So sooner than later, if you have a new use case, please make it known. And of course, please help refine the existing write-ups that do exist.
Okay, thank you all very much. Appreciate it. Oh, sorry. No, go ahead.
From Sean Tanner. Did I miss when the number 2 is coming?
It's in progress. It will certainly be ready before November. Don't have an exact date yet. We're running a little bit behind on getting it read. We were hoping to have it read for this meeting, but circumstances intervene. But so I don't want to promise again and say a date certain. But certainly it's going to be read once and hopefully twice before November.
Other questions? Going once, going twice. Okay. Thank you. I mean, this is great. We are a little bit ahead of schedule, so that will give some room to other discussions.
Don't tell them, we're not.
Thanks
We're not
for
ahead of
letting
anything.
tell.
Don't tell
Okay.
anyone, we're not ahead of anything. So next up is we're going to be talking about requirements. So Andrew, if you could come up and stand in the beautiful pink box.
No.
Hi, I'm Andrew Mortensen, Arbor Networks, and here to present on the update to the requirements draft. Next slide, please. I hope this is better.
Yes.
All right, good. All right. This is a blue screen. I don't believe, oh, there we go, okay. So the update to the requirements draft focuses on these areas here, as you can see, for the changes from the 01 draft. It now has a dependency on the architecture draft, the recently adopted working group architecture draft. We've added some data model requirements. We have DOTS gateway replacing the formerly unique DOTS agent type DOTS relays. We have some discussion of session configuration requirements over the data channel. Some congestion control considerations have been revised, and we have some clarification on mitigation scoping. I'll get into each of these points. Next slide, please. Can someone get the door, please? Thank you. So the previous revisions of the requirements draft had some assumptions about what the architecture would be and some common sort of working group understanding of some of those elements. With the adoption of the architecture draft, we now have a place for those assumptions to be made explicit. So the requirements draft now has a dependency on the architecture draft and tries to clarify things. Any additional architectural things will now be pushed explicitly into the architecture draft itself. Next slide. Data model requirements to date had been a stub. There was nothing there. So there are some slightly more fleshed out data model requirements covering structure, versioning, the mitigation status and request representations, as well as scope, lifetime, and efficacy, as well as trying to make it clear that the data model should be transport agnostic. We did have some feedback during the design team discussions that the data model requirements that have been added to this revision are still very generic, and we could use some additional input here. So we would really appreciate some feedback on these requirements. Next slide, please. The DOTS gateway is, I'll get into this a little bit more in the architecture draft, but the DOTS gateway is a replacement for the DOTS relay. The discussions in Buenos Aires really pointed up the fact that the DOTS relay was going to involve too much operational complexity, particularly when it came to end-to-end signaling. So we've brought the DOTS gateway in as a way to provide some of the similar functionality. It's a function, not a distinct DOTS agent type. It's analogous to the B2B UA, back-to-back SIP server, or DOTS server and DOTS client. At the moment, this draft does not have any gateway requirements. It's only defining the term and the way that it would be used. So we could, again, appreciate some requirements and some feedback related to the DOTS gateway. Next slide. Session configuration. This is a place where the data channel, we've talked about the data channel being able to be used for things like this, setting session maximum mitigation lifetime, resource identifier, so you can pool resources and refer to them by an alias or an identifier, configuring the heartbeat interval, for example. Again, we had some feedback during the design team discussions that this really needs to be, we need to have some same defaults in the requirements. As well as to make it clear that this is configuration, it's optional, it does not have to be done before a signal channel can be established. Next slide. The previous congestion control section just sort of naively said, yeah, we probably won't be sending that much, so it's not a concern. This update tries to tries to make the congestion control considerations more explicit, really take into consideration the concerns raised in RFC 5405. And it says explicitly that the signal channel must have something that handles congestion control, while the data channel is expected to be handled over a reliable transport, in which case the transport itself will be handling that. Next slide. There were several clarifications to be made as well as some rewording, but the clarifications focused on a few areas. Primarily, there was some self-contradictory text relating to mitigation scope and to white and blacklisting, where it did not take into account the fact that we were saying, yeah, you can protect different resources, including prefixes, fully qualified domain names, and so on. So we really tried to make that clear to say that we're referring to resources rather than prefixes or addresses, for example. And we have removed the lookup caching requirement, which we came away from the Buenos Aires meeting believing that the working group had rejected. Next slide. So next steps. One of the things we do need to figure out is if there are additional DOTS gateway requirements. As I said, the DOTS gateway itself is just a logical entity. It's not a unique DOTS agent. So it's not clear to me that there are requirements that we need to cover here, but this is a place where we're calling for them. The data model requirements, as I said, are fairly generic. We will try to make them more focused now that we have a volunteer to write a data model draft. Perhaps we can work together. I wanted to ask if anyone thought that there were information model requirements that needed to be added to this draft. And the security consideration section, as is fairly light. It may need some additional revision, and we would appreciate some working group feedback on that as well. Next slide. This is the URL for where we're keeping track of the working group revisions of the DOTS requirements. Please feel free to fork or add issues, file issues against the requirements draft. The working group members will get notifications and we can continue discussions there and on the list. Thanks. Roland?
Yeah, Roland Evans, our Networks. In the next rev of use cases, we will explicitly include narrative examples of gateways for both inter and intra domain use, and hopefully that'll help coalesce some of the implied requirements and help guide us towards a more formal definition.
Thank you. Anyone else?
Frank Xia, Huawei. Just a question for clarification. You mean currently we have the data model requirement content in this draft, and in your next step you say that we need to have some information model requirement.
I was not saying we needed to. I was asking the working group if the working group believes that we need to add an information model requirement section to this draft.
Yeah, I think actually they are. I don't know. I cannot say they are same thing, but they are totally similar. Information model to derive the data model. So
right. Well, there's an entire RFC on the distinction between the two.
Yeah. I know.
Right.
Yes. So actually, I think if we have the data model requirement or the information model requirement, I think it's okay because they all describe what the information we need and what should they be like something. I think we do not need two parts of.
All right.
They are the same thing from my understanding.
Okay. No, I appreciate that. Yeah. Thanks.
Fleming Andreas, yeah, I would support that as well. I mean, we've seen at least one other group here in the security area, right, that's kind of stuck on this whole data model, information model thingy, and I don't think we want to get overly hung up on that if we don't have to.
That sounds great to me.
Although I think the draft looks pretty good. Data model, yeah, I think a little bit more is needed, but I think that's going to have to be a two-way street, right, as we just gain more knowledge as to what the data model actually is going to look like.
Yeah. Okay. Thank you.
Okay. Any other questions, comments, concerns? Good. Yeah, then we proceed. Thank you very much. And we proceed to the architecture. Oh, sorry.
This is the recently adopted architecture draft. It's stylistically, the slides are stylistically similar to the previous, you may have noticed. All right, so this was adopted from an individual draft following Buenos Aires. And so we've made several notable changes to the architecture draft since adoption. So the document itself has been reorganized. I won't get into that too much, but that's one of the major modifications you may have noted if you just clicked on one of the diff links. We've added a mitigation request triggers section to cover scenarios in which mitigation might be requested. Again, we replaced the dots relay with the dots gateway. In the architecture draft, we go into much more detail about its position. We have eliminated the mode of signaling we've called relayed signaling in favor of the using dots gateway in the path. And we've clarified the use of identifiers to scope mitigation. Next slide. So the reorganization was primarily to eliminate a bunch of forward references in the document. And we've incorporated some of the concepts into the architecture section. Next slide. The mitigation request triggers section was something I was planning to add to my original draft and just sort of ran out of time. So we incorporated it into the working group draft. These are the conditions and motivations for mitigation requests, and they are, as enumerated in the document, manual, threshold-based, and mitigating on loss of the peer dots agent, primarily the dots client. So if the dots server for some reason notices the loss of the dots client, and the dots client has configured beforehand that the dots server should initiate mitigation in that case, that would trigger mitigation as well. These are not comprehensive. These were sort of the three major areas that I was able to come up with, but also in discussions with other people within the working group had come up with. The mitigation on peer loss, I'm not sure if that is necessary, but this was one of the conversations I had with some people within the working group off the mailing list, and we tried to bring that conversation onto the mailing list. So getting some feedback about the utility and value in particular of that mitigation trigger would be valuable. Thanks. All right, so as I mentioned in the requirements draft slides, the dots gateway is this logically concatenated dots server and client, like the SIP B2B UA. We have purposely left out discussion of the interface between the dots server and the dots client that make up the dots gateway. We want to make sure we want to leave that implementation specific, at least at this point, because that interface might just be a database. The two services might be running on the same host. They might be on separate hosts. They may be communicating over some simple REST HTTPS API. But at the moment, the architecture tries to leave that alone. And as I mentioned before, this is a function, not a distinct dots agent type. Next slide. This is a very simple diagram demonstrating that we've left that, that interface alone, and that's up to the implementers. Next slide. Relayed signaling has been totally eliminated. And if you'll remember, those of you who are in Buenos Aires or have been following the draft, the relayed signaling involved positioning dots relays in the signaling path, and following discussion of that, when we started trying to consider end-to-end signaling, it rapidly became clear that relayed signaling itself is going to be extremely problematic, very difficult to deploy. So now all signaling is hop by hop, and the gateway, any gateway involvement is opaque to the dots client. And whether you choose to use a dots gateway is deployment specific. We do cover some cases where we are aggregating signals from downstream dots clients. So the gateway reoriginates the dots signaling, may group them together, or it may be used as a bridge between, for example, TCP connections with downstream dots clients and UDP connections with upstream dots servers. Next slide. Here are the problem areas we've identified. I don't know necessarily that the back-to-back dots server and client interface is a real problem area, but getting some working group feedback would be very valuable as we figure that out ahead of Seoul. Some discussion on the multi-home dots clients. I'm going to get into each of these in the next few slides, but multi-home dots clients have some issues, and I've already plotted with one of my fellow co-authors on discussion here.
So Brian Rosen, I mean, you really are reinventing SIP back-to-back user agents. We got it. It's all okay. But the most important learning we have from all of that is if you don't have security as an absolute fixed requirement on every hop, then you can never get security end to end. So it's all right to do it, but it means that you cannot permit a no security link anywhere.
Okay. So would you, in your view, would that need to go into the requirements then related to
Yes.
DOTS gateway? Okay.
Yes, absolutely yes.
Okay. Thank you.
But I don't think that that's a problem here. I mean,
No.
This seems like you want security everywhere, but our experience with that whole hop to hop thing is if you don't have security on every hop, you can never guarantee security end to end.
Right. Thank you.
Yes, that was fun.
Well, I'm sure everyone's here now had a chance to read these, so I won't read these. Next slide. Move on. One of the things we would really like to make simpler is the ability to discover a DOTS server, so to simplify deployment of DOTS clients. So DOTS service discovery has several different options. Direct configuration, very obviously, you enroll or you subscribe to some DOTS service and you just directly configure which host you need to connect to. But additionally, we would like to consider DNS SRV, DNS service discovery, for example. Obviously, those are going to be problematic if you're trying to enable DOTS during an attack, but they would simplify a sort of general rollout of DOTS. And so we've brought these up in the hope that the working group will have some strong opinions one way or another. So far, we haven't heard any. Next slide. So we have some open issues related to the DOTS, multi-home DOTS client. A mitigation request from a client to multiple DOTS servers can be very problematic. I mean, the DOTS client could do this several different ways, but I've identified here the serial in parallel. If a DOTS client sends a mitigation request to multiple DOTS servers that are in different providers, how does the DOTS client coordinate the winning response? How do the upstream providers know who wins? At what point, and how does the DOTS client indicate to all the others that it no longer needs their help? Are they federated? Are they coordinated in some other way? Bob, go ahead.
Bob Moskowitz, AGG Consulting. Back to the DNS serve, SRV. You're going to need geoloc in regards along with that, because you'll be looking for a DOTS server which is near enough to you to make some value to your attack situation. So it's going to be more than just SRV. It's going to take a couple things together for that to be of value to a potential customer, and that's definitely going to take some thought processes.
Roland Evans, Arbor Networks. I understand where Mr. Moskowitz is coming from when he says geoloc, but I am really violently opposed to geoloc because there's actually no one-to-one mapping or even a close mapping between the real world and network topology. So I think that topology, not geo, but topology. So I think we're on the same page, right? Okay, and then some kind of mechanism where potentially within the DOTS client there might be some kind of constraint, on topological distance, per hop, that kind of thing we can talk about.
So Andreas, I mean, I get the issue as well, but I mean, it's not clear to me that you really need to do something about it in the DNS. I mean, we have Anycast, right, which is routinely used for DDoS mitigation anyway, so we might be able to use that for this connection as well.
Yeah, that makes a lot of sense.
But I mean, fair point. We need to consider at least a mechanism.
Yeah.
Well, down is our networks again. Yes, Anycast is anticipated operationally for configuration of DOTS servers and gateways. So yes, in terms of domain-specific addressing, Anycast definitely will be an operational choice, but it doesn't really help the matchmaking side of things interdomain. SRV makes a lot of sense. I'm not sure about SD in this context, but I would hope that we would definitely take a look at SRV records because this is the kind of application that they're designed for.
Wes Herdiger. I'm not a DOTS expert, but I do know a lot about DNS. Please don't use a text record. Thank you.
Noted. All right. Are there any comments on the multi-home DOTS issues?
There are basically two very crude models for multiple upstream provider mitigations. One of them is completely ships in the night, where you have a DOTS client that is talking independently to various upstream mitigation providers, and there's no coordination between the two. The second one is more of a federated model, right, where two or more mitigation service providers actually exchange status information. That we need to be able to support that kind of model, that kind of federation or coalition type of model. Most of the deployments initially will be ships in the night, but over time, once we get DOTS up and running and off the ground, I believe that DOTS will enable federation where it currently isn't really possible. So we need to be thinking about that as actually a pretty strong medium-term requirement.
Do you think that needs to be addressed in this revision of the, not in this revision, but in this architecture document, or if that should be pushed down the road?
I think it needs to be called out in the architecture document. I'll leave it to wiser heads to determine how much detail we should get into. But I think that we need to name check the requirement and have some verbiage that talks about the fact that we're cognizant of this, because there are two stages for DOTS essentially. The first is to get basic mitigation capability, echoing what's available in proprietary solutions available today, and make it a standards-based mechanism. Then the second, large-scale phase of DOTS is to make new architectures, new topological and commercial relationships and mitigation relationships possible that haven't been possible without a lingua franca like DOTS. And that second medium-term phase is where the federation stuff would really come into play, in my view.
All right, well, when I find those wiser heads, I'll let them know.
Fleming, so just to be clear, you haven't found one yet. So on the coordinating server response, could you say a little bit more about what you mean by that? Because you could see, potentially two different models here, right? One is you say, yes, I have a single DOTS client that's contacting multiple DOTS server, and I somehow need to coordinate what's coming back. Not really clear to me, what it is and why we need that. The other model could see, well, conceptually, I just have, two instances of a DOTS client, right, that just happens to go to two different servers, and what goes on, just like we have DOTS gateway, well, we're not concerned about that. So can you say a little bit more about what is the coordination issue that you're considering?
Well, so what I had in mind was particularly in this case was particularly the first one that you mentioned there, with there's a DOTS client with multiple relationships with upstream DOTS servers. And this is also a case where there might be conflict or overlap in the requests. So if the DOTS server has a request from another DOTS client, and then it ends up with an overlapping prefix, for example, how to coordinate those things on the DOTS client end. Does that make sense? I saw Tira shake his head.
Well, we should discuss more maybe offline.
Yeah. Well, I hate to make this obvious, but Tiro and I had coordinated before, so he was going to mention some of these details. So I'll let him come up to the mic.
Sure. The answer them. I think if you, in our in my video draft, we have mentioned two models. One is peer-to-peer relation, and other is the coordinated. That means that we have maybe some coordination center or some server in the upper layer, and he can coordinate it among the different operators. Not necessarily, but it's a possible way, because we want to solve the.
Please have a structured debate on the mic, not cross and forth, okay? And when you come to the mic, please say your name.
Cisco. I think multi-homing brings various complex deployments in the sense that it could be the same provisioning domain. I could have the same service provider giving me multiple WAN links, or it could be different service providers, and each could be giving DDoS mitigation. In that case, how would the client discover that, hey, I'm talking to two different service providers and they're giving me DDoS mitigation? And how would this work, especially if I have a DOTS gateway, that the client just says, hey, both my prefixes are getting attacked, and how would the DOTS gateway then split the request and send the appropriate prefix to each and say that, hey, these prefixes are getting attacked, and how does it coordinate the response? And we have various problems with SIP with respect to forking and all of that. So the best thing would be the client should discover that it's really multi-home. There are multiple upstream dot servers, and probably there needs to be a mechanism to say the clients also needs to discover multiple dots within the local domain so that it can just send one request and it gets one response. So that we have one-to-one request response and not like one request and n number of responses, which just complicates the DOTS protocol. So I think with each deployment, I think if you have to go, then you have to explain with each deployment whether there are multiple provisioning domains and single provisioning domains, and then explain the multi-home DOTS client scenarios, and then probably it needs to be discussed in the working group.
Yeah, I think that will actually go a long way to clarifying it. Thank you, Tira.
Roland Dobbins, Arbor Networks. Overlapping prefixes isn't actually a good example, because if you're multi-homed, for example, right, you're advertising, prefixes out of both, and so that's not really, I think, the best example to use. But there's a real problem today if an endpoint organization that wants mitigation service, let's say that they're multi-homed, and let's say that instead of using a single overlay mitigation service provider, they choose to use mitigation service that's affiliated with their upstream transit providers. Then at that point, what happens is the organization that is the actual end customer ends up trying manually to coordinate what's happening in terms of countermeasures and protection scopes and mitigation scope and all these different kinds of things, and it's a real nightmare. So one of the advantages of having a status capability between multiple upstream mitigation service providers for a single requesting organization is that all that can be taken out of the manual realm and done, in an automated fashion, so that if mitigation provider A sees that there is a change in attack dynamics that might require additional configuration of the specifics of the mitigation, and it's federated with mitigation provider B, it can send an informational message to mitigation provider B saying, hey, with what the portion of the attack that we're seeing, we have seen a changing condition and have made some kind of change, and mitigation provider B can either ignore that or decide to make a change based on the information received from mitigation provider A. Does that example make sense?
It does. I think that doesn't necessarily cover what Tira was talking about, in particular when he was concerned about the gateway, trying to establish the individual bilateral connections and avoiding the forking.
I understand that. I was actually rewinding. I'm sorry. I apologize for not.
I think so.
I was rewinding a little bit. So my point is that the coordination is a necessary function.
Yeah.
It's something that DOT should incorporate, in my view. That would be a great benefit to organizations that do mitigation service.
And you see that coordination happening.
I do it all the time, and it's a nightmare.
Right.
And we would like to take it, so that, the old movies where you see people talking to two telephones at once, right? We'd like to move out of that type of model and into an automated system where organizations that are doing mitigation could choose to exchange information programmatically.
Right, but I'm sorry, I meant to actually say you see that coordination happening primarily at the DOTS server level across domain boundaries.
It can happen either way. The DOTS client itself, could then do this, but the mitigation service providers are the ones that are seeing the traffic, northbound of the target, and so they're going to have a more complete view of changing attack conditions that may well be masked to the actual, hopefully will be masked to a large degree to the actual endpoint organization requesting service. And so because of that, having the ability to do that if organizations choose to share information in that way, I think is a very significant benefit. And again, that's kind of envisaged as being a bilateral, type of thing.
Yeah, Giovanni Asadian. Maybe I missed something, but is there any consideration with regards Anycast?
In this draft, no, there's nothing related to Anycast, but thank you for bringing it up.
Fleming and Dresden. So what Roland said makes total sense. I'm not sure I see that as part of what we're targeting in DOTS right now, though, right? Because that's between the client and the server. We can discuss whether we should have that in scope or not, but maybe just for now, note that I think, we need to dig a lot deeper here because, at least I don't fully understand what's implied here, with what you're putting up. I probably should, since I'm a co-author on the draft, but
Right.
More work required here, I think.
I agreed. Next blue screen, please.
I'm sorry, please. My computer needs to reboot. I apologize. I don't know why. There's this very big software company, and supposedly they don't do this blue screen anymore, but the screen is still blue.
So if you want to talk through your slides, you can.
I don't dance well, but.
No, should be fine.
All right. All right, so can everyone see?
No, it's fine. I'm back in a
I'll
second.
just zoom and enhance.
It's coming in 1 second.
All right, well, I'm going to be continuing discussion of some of the open issues we have, one of which is redirected signaling. Redirected signaling, this is one of the modes of signaling in the architecture draft, and it really fell out of a suggestion made by Ahmed Boukadir for the requirements related to the need for redirected signaling in DOTS. And in this case,
Sorry.
no, it's fine, thank you. This is a case where a DOTS client may already have a signaling session established with an upstream DOTS server, and the DOTS server for some reason needs to, maybe it's overwhelmed, maybe it's got its maximum number of DOTS clients already connected, maybe there's maintenance, but for whatever reason the DOTS server wants to redirect the DOTS client that has either already got a signaling session established with it or is attempting to establish a signaling session with it. In which case it would then be able to send it, the DOTS client to an additional DOTS server to continue the DOTS session. There seems to be some rough consensus on the utility and the value here. There are some concerns obviously about security and under attack conditions, if you get a redirect, trying to redirect to a fully qualified domain name adds a dependency on DNS, which is maybe not going to work. So we do need some further discussion related to the need for redirected signaling. And one of the points brought up was whether this is actually distinct from the recursive signaling mode that we've defined, which is where you've deployed DOTS gateways in your DOTS deployment, and whether that is enough to cover the same kind of things that redirected signaling can do.
That's Dave Dolson, Sandvine. It occurs to me, it sounds like we're inventing a new session layer from scratch here. Just, for example, if we use, HTTP or diameter or different session layers, that you wouldn't have to reinvent this kind of ways of failing over and so on. Just wonder if, is that current thinking? Is that it's a new layer?
No, it's. I think that's giving us too much credit. I think we did discuss diameter in particular and rejected that model early on when we were working on the draft, though. Yeah.
Is it intended to be a persistent connection? Like a BGP?
That's my current thinking. You would like to maintain a signaling session as long as possible, so you're not trying to perform handshakes under attack conditions.
So that would be
that's me as an individual.
So that would be like a BGP, right? And what would be the BGP model for failing over?
Thanks.
So from an operational perspective, any cast addressing of like DOTS gateways, for example, could potentially help mitigate some of the issues that redirection is intended to address. I think that there's still value in it. I can see it from the mitigation service provider standpoint. The question is, though, as we discovered with the relay concept, does it put a huge knot in what we're trying to do with end-to-end security? And we have to have a clear understanding of that so we can determine whether it's a good trade-off or whether it makes sense to simply rely on operational technique to provide the requisite survivability and resiliency.
Thanks.
Anycast helps for redirect signaling, but since we are using persistent connection, if the signal changes to another server, then if you have a persistent connection, that would get broken. And we had faced similar problems with Deprive, which is using DNS over DTLS or TLS to get a persistent connection. And yeah, there's always be a time period if there is a transition that you won't get responses from the server, and you have to assume it's broken, and you have to start all from the scratch. So that's an overhead there, but that would avoid the complete redirected signaling, and it would work.
Yeah, you haven't run into a magic bullet for that then.
Flowing Andreas. Yeah, I mean, it seems useful to me, but I could be convinced otherwise. I think Roland brought up the operational consideration in the design team meeting yesterday, where given that we actually have a connection in place, you would like to be able to essentially get the entities that are homed in on that one to home in on another entity down the road. Now, there could be different ways of doing that, of course, right? We have heartbeats. So you could fail the heartbeat at some point, say, all right, I got to reestablish a connection. If we got SRV records, you could play around with DNS, right? There are different ways of doing it. It doesn't seem overly complicated to me to have redirected signaling support in there, and it would certainly give you more explicit control over what you want done when. I think it is a distinct, different use case from recursive signaling. It is directly visible to the client. We are obviously moving him somewhere else. Recursive signaling is something different that we're trying to do there. We didn't now, with the removal of the dots relay, make recursive signaling visible to the endpoint. So yeah, I think there are differences. Thanks.
All right, so the recursive signaling is now, it sort of looked like what we're now calling gateway signaling. This is a place where you have deployed a DOTS gateway, so you have downstream DOTS clients, potentially your DOTS servers back to back with a DOTS client, and you have an existing relationship with another entity that speaks DOTS, another domain that speaks DOTS. This can propagate the downstream DOTS signals, it can aggregate them or bridge them as necessary. There are a couple issues here. One of them is whether the DOTS client needs any visibility into this signaling. We've said it's opaque at this point, since all relationships are bilateral. I believe there is some text in there still that says the DOTS server that is operating in the gateway may incorporate the feedback it gets from its additional upstream DOTS server. But I think the larger issue here is probably privacy concerns. If recursive signaling is deployed, I mean, this ties into the DOTS client visibility. There are privacy concerns to the point about the B2B UA. If security is not made explicit in all hops, there's a real issue here. Whether the prefixes or protected resources themselves being requested by the downstream DOTS client should be propagated to some degree to the upstream DOTS client, upstream DOTS server, whether that's a privacy concern for the operators of the DOTS client.
I think the privacy concern is more with respect to not just redirecting the traffic, but in case if there are L7 attacks and the content provider is giving private keys to the DDoS mitigator, then what is the privacy concern that it would even have to give those keys to some upstream DDoS provider that it may not want to give? So I think that's the biggest privacy concern, I think.
Please state your name when you go to the mic.
Cisco.
And we did actually have some discussion of this internally in the architecture draft team. My personal take was that any disclosure of keys would have to be part of some service agreement, and if a provider violated that, that would be reason for termination of the service agreement. But I think that debate is continuing, obviously, within the architecture team.
With all the other baseline measures that we've, I think have general consensus on in terms of confidentiality and integrity of the signaling path, I don't view the privacy as a concern with regard to the recursive model. I don't see the recursive model extending beyond one bilateral relationship. You see what I mean, right? It's going to be one administrative hop away, and that's it, right? I don't see a model where a gateway would then take the information and then hand it off to some other administrative entity. So I don't really think that that's an issue. With regards to the opacity is a feature. It's very much a desirable feature from an operational standpoint. So we want to make sure that everyone understands that being able to shield the internal DOTS layout from outside the span of administrative control is an important operational requirement.
Yeah, I think, Tira, you can correct me if I'm wrong, but I think you were referring specifically to the case where you would be providing private keys for HTTPS, for example, or otherwise TLS encrypted traffic that needed to be mitigated.
Yeah.
Fleming, Andreas, just want to point out with the privacy concerns, it's not that we're completely ignoring privacy. It's just we're not providing any protocol machinery for dealing with it. So there is the whole architecture draft, as you're talking about here, has an operational model in place, and we're saying we're assuming that there are service level agreements in place, as you were alluding to, and part of those agreements are essentially what can I do with the information that I get? Can I, for example, engage in recursive signaling? What am I allowed to convey? So you can say we're taking some shortcuts, maybe from a protocol point of view, but it's a conscious trade-off in terms of how complicated, how much scope do we want to take on. It's not like we're completely ignoring it, though. I just want to point that out.
Thank you. Next slide. A couple of our co-authors who are not here, Rich Compton and Christopher Gray, presented on DOTS at the, if I can remember what this acronym means, the Malware Messaging and Mail Anti-Abuse Working Group in Philadelphia back in June. I think they more or less presented what we had covered here. We had a brief phone call with them. But my understanding is that the primary concern from the attendees, who are largely ISPs, was the authentication and authorization. They're very concerned about having something that can influence network path. They are enthused about it, but also this is the thing that they focused on. And so I think going forward we will try to cover some of these additional concerns. Next slide. All right, the architecture draft is now in the DOTS WG repository up on GitHub. Please open issues and make sure, if you do open issue, to put it on the mailing list for discussion.
Roland Evans, Harbor Networks. Can we go back to the slide that talks about the mitigation triggers?
Sorry, which one?
Keep going.
Right there. Okay. We say manual. We say threshold based, peer loss possibly, and I agree. My personal view is that peer loss should be an optional configuration option in the DOS client. I think that rather than like threshold based though, I would almost say I wonder if we should substitute language and say conditional, because there could be, for example, a chronological component, right? If we have a federated model, right, that we were talking about earlier, where multiple mitigation service providers are sharing information, and one of them, a mitigation service provider A says to mitigation service provider B says, hey, I am seeing attack traffic and I'm now in active mitigation for our mutual downstream endpoint network. And it relays that to mitigation service provider A. A relays it to B, sorry. Then B may decide, based on the condition of having received that message, to initiate proactive mitigation on its own, if that's within the remit of the contract that they have with the actual end customer organization. So I'm not trying to be pedantic, but I want us to make sure that we think about not only the existing paradigms that we use today, but that we think about mitigation, triggering and mitigation termination in terms of a richer informational environment that a system like DOS provides us beyond what we have today.
Okay, thank you. So actually, one quick question. We have one of the points under threshold, and conditional may be better language. We have one bullet point for the threshold base that covers arbitrary statistical analysis. Would that sort of fall under what you're talking about? But is your thinking even broader than that?
Oh, absolutely. So for example, one of the problems today with the DOS mitigation service is that there are often a number of quote hidden dependencies, quote unquote. For example, in the case where the endpoint organization that's requesting mitigation service have their authoritative DNS that's actually being run by some DNS registrar that doesn't have a contractual relationship with the particular mitigation service provider in question, and all of a sudden, their authoritative DNS service is no longer available. That could actually mean that, besides the problem of not having authoritative DNS, that, transit links are being filled because of direct attacks against the actual endpoint organization servers as well. And so, there would be, in that example, there would be some kind of out-of-band monitoring to make sure that authoritative DNS is working. And if it's not, that might be a condition that triggers proactive mitigation, for example. Right.
Thank you.
Open networks. Should we also somehow identify what kind of peers lost, like DOTS client lost, DOTS server lost, application protection lost, DNS from the mention also lost, to make like a broader spec?
Thank you. All right. Any further questions?
Okay, thank you so much, Andrew. So this concludes the portion of the documents we have that have been adopted by the working group. Next up are 4 solutions-oriented drafts, and we're going to first start with Tiru Reddy that's going to talk about draft ready DOTS transport 05.
Is this was the new set of slides from him, or is this the one you uploaded now?
That's uploaded. Yeah, that's the latest.
Hi all, I'm Tiru from Cisco. Next slide. The main changes to this draft in this revision are we changed from REST and moved to CoAP. CoAP is used for both dot signal and dots data channel. Dots signal channel would run over both UDP and TCP, and dots data channel would run only over TCP. Happy eyeballs mechanism was presented in the last working group session, and based on the working group feedback, we changed it to non-normative, and it's only a performance recommendation for the DOTS client to implement. We have added a section to explain mutual authentication between the DOTS agents and how the DOTS client would get authorized. And then the mandatory DTLS protocol profile for DOTS agents to implement, and TLS and TCP extensions for performance considerations to reduce the number of round trips between the DOTS agents before DOTS signal can be sent by the DOTS client. Not much changes to the happy eyeballs mechanism. So it's for the DOTS signal, it's going to run over both V4 and V6 and both over UDP and TCP. IPv6 has a slight head start over V4, and UDP is given high precedence over TCP by default. Next slide. So we are following the recommendation given in 6724, so that this is the order of priority in which the session establishment with the DOT server would be tried, with V6 over UDP followed by TCP, and then V4 over UDP followed by TCP. And then DNS lookup has been changed to be done only during peacetime. Next slide. So this is the main heart of the draft, that we changed from the DOT signal and DOT data channel to use CoAP. So for DOT signal, it's going to be over using CoAP, and then it's going to be using DTLS for security and authentication using the certificates. And it's going to run over both TCP and UDP. And whereas the DOTS data channel would run only over TCP and would get security using TLS. Next slide. So we have used all the various messages that have been defined in CoAP for basically signaling that the DOTS client would use the post message to signal the DOTS server that it's under attack and it needs medication. Post message has been changed to a confirmable COAP message, which would ensure that the CoAP stack would basically retransmit the post message in case if it's lost and server does not hack that it has received the post message. The server can also basically immediately send an ACK if after it gets a post message. That's the functionality of CoAP. Or else it can piggyback both the ACK and the 200 OK response to the client saying it has received and it's processing the DOTS signal for initiating a DDoS mitigation. The 200 OK would also be signaled as a confirmable message so that the server would get an ACK from the client whether it has received the message or not. And then in case if the server has lost and has not received the ACK, it would keep retransmitting the 200 OK. And in case if the client has received the 200 OK and the server keeps still sending the 200 OK because it has not received the ACK, then the client can send an CoAP reset message to say that, hey, I have already received 200 OK, and you can stop sending the 200 OK response. Next slide. So the 4 messages that we have picked post for signaling the DDoS attack, and the client needs a DDoS mitigation, and the delete to withdraw the DDoS mitigation, get request to get the mitigation status from the server, and then the put request to basically say the efficacy update from the client whether the mitigation is successful or not, or it's still saying that it's under attack. Based on the update in the requirements draft, we have also updated the mitigation status get request to use asynchronous messages so that it can get mitigation status updates much faster rather than using a transactional request response model. Next slide. So the simple example is CoAP gives an option called observe, which basically allows the server to send multiple unsolicited responses for a GET request. So the client sends a GET request saying it's interested to know what's happening with the attack, and the server can send multiple unsolicited responses saying, hey, it's starting to take mitigation action. Mitigation is complete. Attack has stopped, so that the client can later decide to withdraw the request. Next slide. Not much changes to the DOTS data channel. It's still going to run over TLS over TCP. It's only changed so that we could use CoAP, and it's basically used for signaling the blacklist and whitelist, and later to withdraw the blacklist and whitelist. Next slide. Okay. Since authentication and authorization are mandatory, we have added a new section to explain how authentication would be done. So, for example, we have taken this example to show that there's a DOTS gateway in the enterprise network, and it's basically interfacing with the DOTS clients. And there's a DOTS server who is providing the DDoS mitigation service. Here, the clients are basically authenticating to the DOTS gateway using TLS. So it's basically both client-side authentication as well as the server-side authentication. That's hop-by-hop authentication. And similarly, the DOTS gateway has to authenticate itself to the DOTS server, and the DOTS server has to authenticate itself to the DOTS gateway using the TLS handshake. Next slide, please. So in this example, we have also shown that authorization is mandated to make sure you don't want anyone to go and request for mitigation. For example, in this case, only an application server is authorized to request DDoS mitigation. A DDoS detector that the enterprise network would have deployed may be allowed to permitted to request DDoS mitigation, but a guest who is just authenticated to access resources within the enterprise network may not be authorized. So the DOTS gateway is going to talk to the AAA server as an example, and basically allow only the application server and the DDoS detector to request DDoS mitigation, but not the guest user. Next slide. We have updated the DTLS profile to mandatory and must implement for the DOTS agents so that they would get benefit of DTLS session resumption, raw public keys, and DTLS heartbeats for checking the aliveness of the peer DOTS agent. Next slide. And the recommended performance considerations, which includes TLS and TCP exchanges to reduce the number of round trips. Questions?
I have one question, Kira. So which set of use cases are you covering with this protocol? I know it's kind of hard to sequence them since the use case numbers are now in flight, but are there any you anticipate not covering? Or what do you think?
We are covering most of the use cases, but I think I saw your comment, and we'll update which use cases explicitly we are covering in the document.
Okay. Yeah, I mean, if you're not doing a particular use case, I think that would actually be really interesting.
We will mention that in the section 3. I saw your comment. Yeah, thanks.
Great, thanks.
Roland Evans, Urban Networks. Happy Eyeballs, this type of signaling, negotiation, discovery, whatever you want to call it. I think it's pretty slick. It would potentially apply to any of the use cases that we've envisaged. However, I do want to point out that for the foreseeable future, most DOTS connections are going to be very highly curated in the same way that eBGP peering relationships are highly curated. So in the near to medium term, there's not going to be a lot of dynamism. But assuming we all eventually get to some happy IPv6 completely dynamic, nirvana or Gehenna or whatever it turns out to be in the future, then this kind of dynamic mechanism to determine the appropriate, address family and communications path would be useful. But it is not. I personally don't envisage it as like a DOTS phase 1 kind of thing, but I think that it's important to think about this for the dynamic future that we're lurching towards.
Yeah, especially when we move to DNS service discovery, and you could discover UDP, TCP, and running on different IP addresses and ports and different IP addresses family. If that makes sense, then this makes sense. Otherwise, we should get rid of both. Yeah.
Other questions?
Can you talk a little bit about the reasons you chose co-op?
Yeah, they were
Sorry,
initially we were
enterprise.
sticking to HTTP, but then the requirements draft had changed, especially to talk about congestion control for UDP, and then it has to run over both UDP and TCP. And CoAP fitted the bill much among the protocols that we looked, because CoAP gives already a functionality of congestion control, that if the requests are retransmitted and there's no response, it gives a functionality of exponential backoff, and it also fits within the MTOs, as it's pretty much that you don't have to handle fragmentation and all that, so it runs over UDP, and it's pretty lightweight, and you want to run it when the link is congested as well. And IOTDSs are the ones which run in the most constrained environment. So I think CoAP fitted the bill, and it looks like REST, right? So it has a look and feel of REST, and for a dots, if somebody is implementing dots, we already have dots, the CoAP stack already available. So it's very easy that we don't have to invent a new protocol to do that, and we can just write applications on top of that. And I also see browsers and all that are getting plugged in and are getting CoAP implemented. So it's going to be pretty easy that even for the manual triggers that use cases talks about, it could be that I could just go to the browser and raise a CoAP request, which works. And I think that fits multiple requirements and use cases within the document.
Yeah, thanks. Following on that, you talk in the draft about the dots gateway being a co-op to co-op proxy.
Yes.
Do you see any issues in that?
Yeah, one issue that I see is, I mean, especially with back-to-back user agents and co-op proxies, right? They always talk about semi-trusted or entities that you want end-to-end encryption, right? Where they talk about object encryption. Like back-to-back user agents always talk about that, hey, they're not trusted, they could be run by service providers, and we need end-to-end encryption. But in this case, I think the architecture document clearly needs to articulate that DOTS gateway is a fully trusted entity, and we don't need end-to-end encryption, and hop-by-hop encryption is sufficient. Otherwise, we will run into all the rat holes of how do you get object encryption on top of DTLS, and that would pretty much complicate DOTS. Yeah. Co-op proxy supports both the modes, so I think for us, it's a fully trusted mode works for us.
Okay, thank you.
Okay, thank you, Timur. Next up is Jerome Frankosic talking about IPv6 signal options 00. In the pink box, please.
Thank you. I'm Jérôme François Pamolinière. So you can go to the next slide. So what we propose in this draft is let's say an auxiliary mechanism for the signaling. So the idea is not to substitute the regular mechanism, but to basically benefit from the first instant of the attack, where even if you're in this instance, where even if you're under attack, you may expect that you have still some traffic that is going through the network. And the idea is take benefit on that, embed information is such outgoing packets in order to signal the attack. So how we propose in this draft is to use the IPv6 hop-by-hop option header, because it provides a manner to do so in an opportunistic manner in order to embed the signal into the IPv6 packet, and then to basically spread the signal by re-embedding at some capable router, which can just copy the information. And of course, this is, we'll maybe enter more in detail into that, but it's more intended for the intra-domain use case. So next slide, please. So also basically we have defined the header to be used for that. So we based our work on the transport draft. So we have the same attributes, and we added some of them, especially in order to support our proposal. The first one is mainly we need a TTL in order to avoid, because basically what we will do, we will just duplicate the signaling to many packets. So we need to avoid that, to do that indefinitely. And of course, as we are not embedding the signaling information into packets that will finally will go to the server or to the gateway. So meaning that this packet can be sent to other destination in order to convey the signal at certain point of the network. So meaning that we need also to embed information regarding the last destination, which is, for example, the server of the gateway. So some of them are fixed lengths, others are type length value, but this is some details. Next slide. So here just an example of that we provide, where of course you have the fixed length value at the beginning, and then you have other value, but you can find standard information that has been defined, for example, the target address and so on. Yeah. Slide. So just to clarify a bit, we have here a very small example. So next slide, please. So, okay, then there's an attack. So the client will first initialize the regular communication, for example, with the server for request as a mitigation. But at the same point, it will select some well-chosen packets that is emitting in order to IPv6 packet, of course, to embed also the information. So next, please. These packets are then, of course, routed and go through the network. When they arrive on non-capable routers, they are not, of course, handled because the option will be not handled by these routers. And this, yes, you want to?
Roman Dinadu, CERT CMU. I guess I'm wondering, how does the server know we're switching over to this other method?
Oh, sorry?
How does the server that's supposed to be watching for these newly special environments, how does it know it's switched from the previous signaling method now to this new signaling method?
So yes, so the idea is that we have an ID also we have kind of ID in the information that we embed. So there is the ID. We rely on the same attributes, in particular the lifetime also, to identify, so that when the server will receive that kind of packet, we need, of course, it has to extract the information for this, from the option. And then it should be able to identify, thanks to the ID, of course, the message information is also signed in order to know from which client it comes. And it should be able to identify which request it is.
So just to make sure I understood, so there's the normal signaling channel. In addition to the normal signaling channel, it's actually watching the traffic itself for the embedded options.
Yes, it's so you have both. So it's the regular one, and you have this opportunistic way. They should use the same kind of ID, so that the server will know that it's the same request.
That seems tricky.
Roland Dobbins, Arbor Networks. I apologize in advance for asking a stupid question. Is the purpose of this to serve as a secondary signaling communications channel in the event of congestion? Is that the purpose of this?
Yes, it's a kind of secondary channel, but we have no guarantee on this channel. So meaning that.
So here's the thing, right? In the discussions that we had to date, I'm not sure if you had a chance to look at that. The possibility of the in-band path, right, between the DOTS client and the DOTS server, or between DOTS client and DOTS gateway to gateway, whatever, undergoing congestion disruption is very well understood. And while in-band signaling is today, unfortunately, the norm from an operational perspective, signaling can be done out of band as well from a topological perspective. So this seems kind of an elaborate way of doing something that we already have operational practical mechanisms of doing, to ensure end-to-end connectivity in the event of link congestion or disruption, or unless I misunderstand your purpose here, which is entirely possible.
Yes, you can maybe which ID, and it was not clear when I said it. This IPv6 packet you don't create, especially for the signaling. This is, other traffic or packets from other applications, other traffic, and you just add the option to this. Just embed information
I understand. And relying, you're talking about actual IP options, correct?
Yes.
Yeah, you understand that relying on IP options is not necessarily a good idea because of filtering considerations and punting considerations and hardware-based routers and things like that. So a mechanism that explicitly relies on options for a critical type of signaling, I'm not sure that those two requirements go together very well.
Yeah. So I saw your point. I have, as I mentioned, 2 points. The first thing, and that obvious first is secondary mechanism. We will not substitute the primary mechanism. It's just a way to have more chance to reach the server. And so the second point, we got the comments on the deployment issue and the use of IPswitch option in network. I think then it's a choice. Okay, we can just say we drop every option because it's entails overhead over routers. That's for sure. But at some point you can also just you can specify which option you allow, and you can legitimately think maybe that it might be good even if you entail some overload. You are already even under an attack, and so it can be good even maybe to try to signal the attack even with some cost.
Okay, Mario Georgescu, somewhat related to the questions before me. So on the use of the hop-by-hop option in IPv6, have you considered any middle boxes that run traditional technologies, for example, NAT64? So if you have two IPv6 and IPv4 specific domains, what happens then if you're trying to use this method?
We don't, yes, we did not go until this point yet.
So yeah, maybe you would want to note that, have some kind of note in the document. Yeah.
Thank you.
Fleming Andreasen. I'm not sure I fully understand, so let me ask two basic questions here. The first one is, what is the destination IP address in the packets that you're sending out? And the second one is, why do you think that your packets are going to make it to the DOTS server if the regular DOTS packets are not?
So for the first question, I think this is basically we let's say we don't know. Then it's the rule-based, it's the definition of which packets you will select to basically mark this packet with information. You can say all packets that is going through, but this is very, of course, costly because you will mark every packet. And you can select, for example, the one who are, let's say, going towards in the direction of the server. I'm saying that if you have different, maybe.
How do you know that?
Depending on the final IP address. If you assume that you know your network, you know where is maybe the gateway, and you know what are the host routers located and other hosts located to the gateway, you may first define rules such that you will first mark those packets.
So your assumption is that for this to work, we would have to have access to the routing table, and then based on that, be able to say, all right, if I send a packet, what's this, destination IP address? I think there's a DOTS server on that path, and therefore I should mark this packet.
Yeah, I think it's something that it's basically configured by hand. We propose a rule-based mechanism, and then it's up to the guy to configure what he thinks is good, which packet. So it's based on some kind of filtering of our packets. And so the idea then is, by doing so, you will multiply the number of paths you will use to reach the server, and you will also take the benefit of the first instance attack, trying to mark the first IPv6 packet going out until you reach maybe.
Okay. So I think I understand that part. I'm not saying I agree with it. I think I understand that. Second one then is, why do you think those packets are going to make it all the way to the DOTS server when the regular DOTS packets are not?
And I'm sorry, before you answer, I just want to say we're cutting the line because we have to keep moving. So, Roland, you're the last one.
Oh, so yeah, the why you think so is as maybe just click on the last of this slide. Okay, so The idea is that you will take benefit of all the potential IPv6 packet taking other paths, and maybe going not to particular area of the network where there is no congestion yet.
Okay. All right. Thank you.
Basically.
Roland Dobbins, Arbor Networks. I'm just a router monkey, so I'll just be kind of straightforward here. I believe there are a number of prevalent operational conditions on real-world networks that preclude this model and the use of this particular technology. I personally really appreciate the thoughtfulness that you put into this, but I think that what we might want to do is, if you want to continue looking at this, that we should probably have some good on-list discussion about it, because unless I'm missing something, this really is not going to fly on the real internet, as far as I can tell. Maybe I'm wrong, but let's have some on-list discussion about it and talk more about it, okay?
Yeah, sure. Thank you.
So if you could tie it up in the next 2 to 3 minutes. Thank you.
Okay. So yeah, just you can just go through, and I think it's basically what I rapidly described, that you have some kind of filtering of IPv6 packet. Next slide. Yes, there are some, of course, deployment considerations that we tried already to address a bit in our draft. Okay, of course, we are more envisioning the intra-domain use case because you have more control on what you can force to do on your routers. Next slide, please. Also, some security consideration. Mainly, we propose to use a signature mechanism. Using some state-of-the-art techniques for that. And next slide, yes, mainly yes, it's what you say. We are really willing to have some comments and discussion in the mailing list. So thank you.
Perfect. Thank you. If you have additional comments on this draft, please save it for the open mic time. Next up is Alex Zhang talking about the IPFix extension 01 draft. So, into the pink box, please.
Okay, good afternoon. My name is Samuel. This is the first time I come to the IETF conference, so
welcome.
Please forgive me, and I'll give your suggestions if I make some mistakes. Okay, next. Here is an example architecture of DOS. As a part of the whole solution, I think the first thing that the network devices should do is to measure the network traffic and report the measuring results. So I think the enhanced and standard telemetry information will be beneficial and suitable for operators. That is, with the standard telemetry information, operators can leverage current existing devices to be involved in DDoS attack detection. On the other hand, it can improve the ability of detecting DDoS attack and even more exceptions. Next. Here are I list some changes from version 0 to version 1. I removed some incorrect examples. For example, in version 0, it says some small sessions will have small characteristics. I think this is not true, so I removed it. In version 1, there are two improvements. The first is we clarify the difference between collection sampling and packet sampling. And the other improvement is we propose some new IEs that can be used to detect DDoS attack or even more exceptions, such as a fragment attack, out of order attack, and some others. Next slide, please. So the problem is why we can't use the current existing technologies to detect DDoS attack? Why don't we? What's the challenge of the current technologies? let's consider the two existing technologies. The first is packet sampling, and the second is IPFix. In packet sampling, there are many detailed sampling technologies, such as count-based, time period-based, or even attributive filtering. But I think it lacks session semantics, so it cannot cover some scenarios. So we think we must improve it to build the association way of two directions of when sampling. And IPFix works well for some traditional and classical DDoS attacks, such as SYN flood attacks and ACK flood attacks. But it is not. It cannot cover some more exceptions. So we think it is not fully sufficient.
Considering the flow, may I suggest to have clarifying? Is this a clarifying question or a discussion that you have, Roland?
Neither. I'll wait.
Okay, so for maybe we take clarifying questions immediately and discussion at the end. Does this make sense? Okay.
So, such as I will give some examples in the next pages. Okay. The first improvement. What is the solution? The first is collection sampling. Here I list the key features. Firstly, it provides session semantics. It is important to detect some kinds of attacks. And another feature is if one session is sampled, it means all packets that are belonging to the collection should be captured. Since collection sampling is appropriate for detecting DDoS attacks and some exceptions, someone will say will doubt its performance in real deployment in operators network. I think there are some possible solutions, such as, for example, if you can install some SAL rules into the device to discard the video traffic when you are sure that there is no attack after human analysis. Another method is to change the hash value periodically. Next slide. Oops. Here I list the new information elements we added. Please note that current solution is just a complementary of current IPFix. I mean, these new IEs should work together with current IEs in IPFix. Here, I give some examples. Let me take TCP out-of-order attack as an example. If the network device finds that the majority packets of one collection is out of order, then it will judge that it is a DDoS attack, and it is not caused by multipass, such as load balance. Another example is fragment attack. Since we try to catch all the packets that are belong to one collection. So the network device knows the state, and they can find the fragment, whether there are some packets with overlapped offset or even arrow flags, or the fragment packets with arrow flags. Next. We do some tests in operators networks using the solution, and the test results show that it can increase the detection accuracy and reduce the false alarm. Moreover, it can also help operators to find more exceptions, such as out of order attack, HTTP storage attack, and some others. Next. So we welcome your comments and suggestions. And the next, we will do more tests to compare with current IPFix. In this version, I do not give all the detailed description of each IEs. For example, the TCP control state bits, it is complicated. So I think it will be added in the future version. And we note that in version 1, I just give some typical examples, but these new IEs can be used to detect more exceptions, such as a port scan attack or a host scan attack. Yeah. Next.
Yeah.
That's all. Your comments, please.
Hi, Roland Evans, Urban Networks. Can we go back to slide 4, please? How do I say this? There are multiple statements on this slide that are demonstrably factually incorrect. I had a good talk with Frank yesterday, and I agree that, well, there's, I think, it's a number of misunderstandings about the level, about the granularity of detection and classification that can be done with classical layer 4 flow telemetry today. It's actually, you can infer a great deal more than a lot of folks seem to think that you can. I think routers don't understand connections, right? They don't understand connections. It's not something that a router ASIC understands. Now you can certainly have probes, whether they're standalone probes, whether they're probes that are built on to add-on line cards that are optionally deployed inside a specific router. I do agree that there is additional potential value in some more granular classification at the micro level. However, I think that prior to proposing reopening a closed standard, that there needs to be a firm understanding of the current state of the art. I believe that there needs to be some sort of consensus about the current gaps that should be addressed. And I don't think that we're there here, because the actual underlying facts here are not facts. My suggestion would be that we take this issue of more granular classification and let's talk about it as kind of a separate issue, because it's not really related directly to dot signaling, which is our big push right now. And let's see if we can build some consensus around that. And in particular, it's important that we understand that with IPFix in particular, that IPFix supports enterprise information elements, right? And so you say that you have an implementation, which I assume is running on some kind of feature card in a router or maybe a standalone probe or something. Quite apart from the actual standards process, there's nothing that prevents you from generating an informational RFC and publishing it with all of the different fields and functionalities and so forth. And so I think that what you're talking about has broader implications far beyond dots. And I think there needs to be some broader consensus around it.
Before you answer, if I could just close the line after Tobias.
Through Cisco, today most of the firewalls do send a lot of telemetry information in addition to what you already described, right, for analytics and various other purposes. They're all proprietary information. We use proprietary IE for signaling that for analytics. So can you please explain the rationale behind standardizing this and what is the advantage that you see?
Maybe I can answer to that, unless you want to.
If you could answer quickly, that'd be
Yes.
great.
Because actually that was kind of the point why I came up here. So Tobias Gondrom, Huawei. So we did see that there is an advantage in having additional IEs in IPFix in terms of better detection. However, we want this to be available in a device-neutral, vendor-neutral network, meaning the operator can have devices from plenty of other vendors, and we want still the solution to be beneficial to the operator. So that's why we want to bring it here. I mean, from a big vendor perspective, we could just build it and like ship it and say, oh, you can only use X vendor. But actually what we want it to be available for multi-vendor devices. And for that, we believe it's useful if the IEs are standardized in some way so that Cisco and others can have the same IEs. And then the operator can benefit from that enhanced detection capability.
And Alex, I want to take the last question. Could you help me understand which use cases this use case maps against, or which one it explicitly will not be covering?
You say the use cases?
Yes, so this is a solutions draft. So of the dots use cases, whichever way is easier to explain it. So which ones it covers or which one it doesn't cover?
I'm also the co-author of this draft. Can I answer this question? I think current use cases are mainly focused on the call for help signaling among those agents. But we also mentioned that this signaling can include some telemetry information. So actually, I think it implies some use cases that we can have this information for the detection of DDoS attack. But just some implication of this. But actually, there's maybe we need some more clear description about this. Yeah.
Okay, thanks. Can that be written up and put in the draft? So it's one of the things we're asking of all the protocol drafts, if you could strictly align to the use cases so it's easier for the readers.
Meaning, please write a use case and send it to the use case team.
Okay.
Do I understand you correctly?
Oh, no. What I was saying is in all the protocol drafts, make an explicit citation to the use case draft, and to the degree that's helpful, talk about which one you're covering. As we get closer to figuring out what we're going to do with all the protocol drafts, to make, I mean, this is one of the ways that's going to make it easier to understand where we're getting coverage of which particular use case.
Okay.
So thank you. Okay, in the interest of time, we have to keep pressing. Thank you, Alex. Next up, we're going to be talking about the interdomain mechanism 01. Frank, in the pink box. Thank you.
Okay, thank you. Hello, it's Frank Xia from Huawei. This is another DOS solution draft, and previously we call it interdomain mechanism. That's because that at the beginning of the DOS working group process, we think that the interdomain coordination among the multiple operators is very useful and essential scenario for operators, because that operators can share their capacity, their resources, and can help each other. So we try to identify the use cases, and we output the mechanism draft. Currently it's 0.1 version, and I think in last session, Roman has asked us if this draft cover the intra-domain use cases. Actually, we think that this solution should actually we just define the signaling message and their operation among those agents. So obviously it covers both the intra-domain use cases and the inter-domain use cases. So that's some background information. Okay, thank you. Let's see what's the change from the 0.0 to 0.1. Firstly, like I had said, we add some content to clarify clearly that this solution covers both of the inter-domain and the inter-domain use cases. And I can answer to the chair that we think that our draft, our mechanism, signaling mechanism can support all the use cases.
That's perfect. Can you just put the text in there as well, like I asked for the last one? That's Thanks.
Yep. Okay. And about the content. Okay. Second point is that we reconstructed some basic requirement and use cases content. We divided them with more clear logic into the three parts. The provision requirements, which means that the DOS client should register and announce itself to the DOS server and process some capability negotiation among each other. And the coordination means that when the DOS client are being attacked, how it call for help to the DOS server, and also they should exchange some information, some status among each other. And another important problem we think is about the returning path requirement. How can we return the clean traffic to the DOS client? Okay, so we restructure this part of requirement content, and we think that maybe this content, this part of content should be merged to the requirement of the use cases, because it's not closely the solution content. Okay, and I think the most important change of this version is that we redesigned the DOS signaling messages and their related attributes. We have done a lot of changes to our previous message definition, because we find that our DOS protocol, especially for the signaling channel, what we need is asymmetric and unidirectional message exchange among the DOS client and server. So they are the stateless connection. So because of this reason, we deleted some response, some ACK messages. So we try to make the messages simple and make their attributes more have more correct meaning or information that it should have. And also, okay, and thanks for our new course from the Comcast and the Charter. We have done a lot of text modification, and we have improved a lot on our mitigation request and mitigation status message. That's okay. In the next 2 pages, I just want to briefly introduce our understanding of the possible DOS architecture. And I think it's they are especially for the inter-domain use cases. But that doesn't mean that our solution cannot use for both use cases. Actually, I think we have already some discussion about the two model of the DOS architecture. One is that every operator has some peer-to-peer coordination relation with other operators, and when it needs some mitigation service, it can request to its up layer operators And this is but for this model, we think that there are some cons. For example, because we do not have a centralized server or something there, so every operator has only the incompleted information of the potential resources that it can use. So so maybe this mitigation service is not optimized, and it is possible to repeat several times to get the last mitigation service. So it costs time, and the configuration is complex because we need to configure each other to its peer relation. So that's our understanding for this use case, and so this architecture. And next page. Another possible architecture is that we have a centralized, we can call it orchestrator or coordination center, which means that all the operators have the direct relation with this centralized orchestrator. So every operator's register its resource, its capacity to this coordination center, and when anyone need help, it just send its request to this center. And this center, because he has a overview information of all the resources, so it can do the coordination work. So, and it's very it's more quicker than the previous one, because it's just this operator asked the center, and the center decided which operator can help him. So we think that it has some benefits. Okay, and next page. And come back to our solution, our secondary mechanism. I think from the general perspective, there are some very basic requirement or thing that we need to do. Firstly, is about we should guarantee our signal in China and the data channel is secured. So we should have some mutual authentication among the DOS agents. In our draft, we list some existing way that can guarantee this, but it's not so detailed. So I think we need more content about it. And in current draft, we use JSON to represent the message format, message information. But it's a possible choice, but it's not the only choice. Let's see our later process. Okay, next page. Okay, this is our definition of the message, DOS message. We have two categories of message. The first category is for the provision stage. So it mainly includes the register message and the register canceling. So in the register message, it does not only for register itself. It also deal with some capability negotiation among the DOS client and DOS server. For example, we can see that in the register message, the DOS client can send its required protected zoom to the DOS server, and it can have a lot of information to represent this kind of thing. And the DOS server can assign alias name for this protected zoom, and in the later stage, signaling stage, they can just very easily to use this alias name to ask for help. And also, the DOS client can send its right list and the blacklist requirement to the DOS server, and it can negotiate the transport profile, which is TCP or UDP or COAP, to the DOS server to achieve some agreement with DOS server. And the DOS server can respond to the register message with some information that the protected zoom alias, its maximum throughput BPS, PPS, and its longest last time something. And so yeah,
and the registered canceling information. Okay. And the next page is about the signaling stage.
Excuse me, Frank, time is getting tight, so you're over your slot, so maybe 2 more minutes?
Yeah.
2 more?
Okay. Yeah, we can directly see this this diagram. For the signaling stage, we define the several messages. First message is the mitigation request. So the DOS client sends this to DOS server to ask for help, and then if they have some, if the service is provided, so the DOS server can send the mitigation status message to DOS client, and also the DOS client can send its mitigation efficacy to tell its health condition to the DOS server, and they have heartbeat message for the affiliate check. And when the DOS client want to update its protected scope, it still sends the mitigation initiation request message to the DOS server. So we multiplex, we reuse this message, and then they exchange the status. And when the DOS server finds that the attack has been mitigated, so it notifies the DOS client, okay, you can stop it. So the DOS client sends the termination request. Then the DOS server sends it with the status message to tell the status that, okay, I have stopped my service. So the client sends the acknowledgement message to the server. So that's the whole process of the signaling stage.
Please come to a close.
Oh, okay, sorry. Yeah, I think I welcome everyone to see our message because it's very detailed, but it's based on our good discussion with a lot of operators from NTT, from Comcast, Charter. I think in this version we have improved a lot of our message. So next step, we will keep on moving our message specification and the operation process. And also, the very important part is about the transport protocol and the secure mechanism. Yeah, that's all. Any comments? Thank you.
Thank you, Frank. We have no time for comments, so we're moving on to the last of our presentations. So Daniel is going to be talking to us about some related work to I2NSF. Yeah, so I uploaded them during the meeting, so you're going to have to get them down from the site.
I will need 1 minute to get it.
Hi, so 2 minutes?
Yeah, no, you have your full 5 minutes.
I got 5.
Unbelievable as that
Right.
sounds. No, we're just downloading the slide, so if you want to open up, please.
What I'm going to talk is something related to DOTS, but it's not really DOTS. DOTS is about signaling you're under attack. And to mitigate an attack, usually what we can, you can notify that you are under attack, but then to mitigate that, you might need some collaboration between different domains. Typically, the use case would be you have a cloud, a web server within the cloud is signaling he's under attack, and then, well, the cloud provider is probably interacting with the ISP saying, well, can you block this type of traffic, for example?
Excuse me, Daniel, the slides are now behind you.
Okay, so yeah, so that's typically the use case we address. So different domains, and they want to interact in order to mitigate an attack. So the problem is that when you can interact between different domains, what we want is a collaboration. We don't want an orchestration. So next slide. So a collaboration must be flexible, and well, you need an agreement somehow. And if you ask, well, in this example, the cloud might ask the cloudlet to address some traffic, but maybe this ISP is not able to handle the whole traffic or the whole treatment. So what he's going to say is, okay, I can handle this part, so it might be 10 query 10,000 query per second. I can handle those, but the other I can't. So I have two kind of flows. Flows that is considered by treated packets and flows associated to non-treated packets. So that's how we envision the collaboration in a best effort mode. Next slide. So the collaboration agreement is, well, we have an ID, we have the two parties involved, initiator, provider. The type of collaboration, best effort, means, well, the collaborator is handling in a best effort way what he can. Some resource involved. The type of service, because when you ask for a collaboration, usually that's for something. So in this case, it's a security service function. Well, the collaboration has an expiration time. It's not indefinite. It can be renewed, of course, and so on. But and some interconnections. Well, should I receive the treated packet on this one or the non-treated on this path? Direction is to know if it's downstream or upstream. Next slide. So, well, the question we have is, I think that's pretty easy, but we would like, well, if we want to be able to negotiate, we have to agree also on the terminology we use. So in this case, when you want to collaborate with a specific service, we need to find a way that both parties agrees on what this service is doing. If you ask for a firewall, firewalls means a lot of things for different people. So that's part of the challenge. The other challenge is, how do you define the resource? Do you use the C groups, for example, terminology, which is very specific, or do you use more the AWS terminology, which is much more high level, but it's only an indication? Well, so these are kind of the challenge. The protocol we currently design is based on HTTPS and JSON. It's very easy. You send a set of proposals, and if the provider agrees, it sends you back the proposal is agreeing on. Next slide. Then, well, we have a different set of operations that might be helpful to handle the collaboration. So it's mentioning that it's stop, we end of the collaboration. We want to renew that. We want to upgrade resource. And the last one, I forgot what it means, but it's probably something bright. Next slide. So yeah, so well, it's typically a two exchange protocol. We're using JSON, but we don't. Well, some of the questions we are asking is some feedbacks is, do you think Yang would be more appropriate, for example, or do we have any other way to do that? Are we doing something that have been done 5, 6, 7, and many more times? So, well, we're waiting for any feedbacks we can receive, and you can send them on the mailing list. It will be more than welcome.
And we have time for maybe one question.
I have a practical question. So this draft is discussed in I2NSF. Is that correct?
I think, I'm going to present it in I2NSF.
Okay. So where do you said we can send feedback on the mailing list. Which mailing list are you referring to?
Well, I'm on
DOTS or
both,
I2?
so, I mean, I will take comments from both mailing lists. If you send it on dots, I'm fine.
Okay, what's the preferred one? I2NSF?
I would recommend I2NSF.
Yeah,
Yeah,
I would
good.
also recommend.
Okay, so then.
But if you send it on dots, I will read it.
Yeah, that's fine. But then, as working group chair, I recommend you post it to I2NSF, and there's no need for cross-posting. I mean, I think we have good traffic on both mailing lists already. So thank you. Yeah, thank you.
Thank you. So wrapping up, I mean, we're running to the end of your time, and the time. I appreciate we're keeping you from the social. So 2 quick things. Just wanted to remind everyone that tomorrow during the lunch session, 12:30 to 1400, we're having an implementers design team, and I'll let Tobias pronounce the room.
Yeah, it's in the room Köpenick number 3. There's a famous literature called the Hauptmann of Köpenick, which is like a German book. So maybe that's probably the reason why this is the name. Anyway, so from 12:30 till 1400, I think one of the key challenges for us is to see some running code. So we are seeing progress on the specifications, but as you know, IETF is about rough consensus and running code. So I hope we can see some people tomorrow to discuss implementations and to see whether we can do some compatibility tests eventually and so on. Because we want to do more than just papers. So
really
yes,
aggressive.
thank you. Okay, with that, I think we can.
Interim meeting, so
Yes, interim meeting.
next week or the week after, be on the lookout for a poll about scheduling the interim meeting. We want it 6 weeks out, so please respond and we'll do the scheduling, but otherwise.
Yeah, thank you very much, and thanks for being here, and hereby we close the meeting. Thank you.
That dongle is not very cooperative.
Yeah. Yeah, I don't know, this was.
Oh, that one, I. Your work is not being cooperative.
Yeah, the dongle for the projector.